Hello and welcome to Uptime is Everything, our next iAdmin session. It's my privilege to introduce our keynote speaker, Phil Godfrey. Phil is a director of solution sales engineering for Park Place Technologies. He has extensive sales and engineering experience and often leads some of our most challenging customer cloud migrations and infrastructure optimization projects. Just as a quick reminder, please add all questions to the Q&A tab. If we don't get to your question, we will add it to our live Q&A at the end of day two, Wednesday. And any other comments that you'd like to add can be added to the chat feature. And now I'll bring on Phil. Thank you.
Hi, I'm Phil Godfrey, Director of Solution Sales Engineering for Park Place Technologies. I've been in the IT industry for around about 25 years, and I've lived through and fortunately recovered from disasters ranging from network core outages to complete storage loss in a virtualized environment. Knowing the pain from both a business continuity point of view and from an IT point of view, recovering from these events, I believe the extra time and money spent planning for these types of events and implementing solutions to prevent them is time and money well spent. Today, we're talking about one of the most critical objectives for every IT organization. That's operational resilience, which drives uptime. As we've just seen from Steve, it's dropped out of the top 3 concerns, but it's still a thing of concern for 42% of the respondents to the survey. As infrastructure becomes increasingly hybrid and distributed, ensuring operational resilience has become more challenging than ever. We're going to take a look at some of the IBM technologies which help build resilience and minimize downtime. In the IBM ecosystem, there is more to uptime than just high availability. Please join my colleagues in other sessions talking about storage, maintenance, and running 6.7 on Power 11 to discover more. We're running multiple sessions in different threads simultaneously, so remember, you can always catch them on demand if there are any clashes of those sessions which you want to attend. If you're like me and joined the IT community when only needing to run environments 9 till 5 was pretty much the norm, the requirement for 24/7 access to systems was limited, let alone the 6 nines availability built into the Power 11s, which we've just heard about, which the businesses are now demanding. Businesses and technology have changed dramatically during the past 20 or so years, and uptime is not just a nice to have anymore. It's a business requirement and absolutely necessity to survive. Every outage impacts revenue, reputation, operational productivity, customer confidence, and potentially compliance obligations. That's why operational resilience has moved from an IT objective to a board level priority. Beyond all of these, in industries like healthcare, applications being unavailable can impact patient care and can literally become life and death situations. Nowadays, it's rare to find an organization which is not running a combination of, say, traditional on-prem environments, IBM Power workloads, cloud native services, legacy business critical applications. These environments are often independently managed by different teams, but are very much interdependent. This means the failure of one component can quickly impact service delivery elsewhere. Many times you'll have maybe an x86 system being the front end and a power system being the back end of a business critical application, or a legacy application running on an outdated operating system due to compatibility issues with the later OS, but is feeding a centralized data hub on which business relies for multi-million-dollar transactions. Beyond the immediate interruption and those frustrations associated with it, outages can cause missed transactions, so loss of income, service delays, SLA penalties, and probably the worst, the long-term reputational damage. I still remember the time when my bank had a system-wide issue and caused the embarrassment when transactions were declined. It's always at those certain times when you're taking someone out when that sort of thing happens. For mission critical workloads, even a few minutes of downtime can have a significant impact. We see here from a 2024 study, 1 hour of downtime can cost up to $5 million. That means 1 minute of downtime is just under $85,000. With these additional costs, we also see a knock-on effect that most people don't realize, and that's existing budgets being lost in moments. Someone needs to pay for those losses, and the easiest budget to take it from is quite often IT. When high availability, or HA, was first introduced, we thought it was just about redundancy or having two of everything. Two servers, two SANs, two connections to the network, and obviously some data replication between them. If anything failed, we'd crank up the other system and would be up and running in a few minutes or maybe an hour or so. HA these days is still about making sure that we have all of that redundancy so that no one individual component failure brings down the whole stack. But it's also about how all of those components support the environment in such a way that it continues to operate. Resilience needs to be engineered at all levels of the environment, from the hardware, the OS, the middleware, application, and communications. So we've looked at why it's important and a very brief history of high availability. Now we're going to take a look at some of the solutions which IBM bring to help tackle the issue. So what is Power HA? It enables clustering across IBM Power servers, running workload on two different systems. It provides automatic failover if anything happens to one of those systems. It reduces planned downtime, allowing maintenance to happen on one of the systems at a time while the other runs the active workload. And it provides protection for IBM i, AIX, and Linux environments. This ensures that if a node fails, workloads can fail over rapidly with no or minimal disruption. So what does this mean in practice, and how does it work? So what we have is constant health monitoring. Both network and disk heartbeats are used to ensure that those nodes are alive. Any failures are automatically detected, and it determines which node should be the one running and avoids the dreaded split brain scenario where both nodes running having lost communication with the other. It automatically executes the failover. Anything which needs to be stopped on the failed node and anything which needs to be started on the live node or transferred over to the live node is done so. And continuity. If we've got resilience engineered across the whole stack, as I mentioned earlier, users will be using a new node, possibly without even noticing anything has happened at all. I mentioned a couple of slides ago about reducing planned downtime. And this is just important as reducing unplanned downtime. It may even be more important, as planned maintenance hopefully happens a lot more frequently than a system outage. But our users are still demanding that 24/7 service. Power HA rolling updates enables upgrading Power HA System Mirror software on one cluster node at a time, while keeping applications running and highly available. Supported from version 7.2, this keeps the cluster online in a hybrid state where nodes or different versions coexist temporarily. A Power HA controlled failover is a planned operation where resources are moved intentionally, such as application servers, IP addresses, shared storage, from the primary node to a backup node. Unlike an unplanned failover, a controlled switchover ensures data consistency and minimizes downtime to almost zero, usually for maintenance, but is widely used for testing purposes. Even with the best data centers in the world, something can go wrong to cause a site-wide outage, as we saw recently with AWS in the UAE earlier in March this year. We hope that nothing like that will ever happen to us, but we need to plan for it. So it's imperative that resilience now extends beyond just a single data center. IBM supports hybrid resilience strategies through cross-site replication, geographically separated failover, and cloud-based recovery options. This means that workload remains protected even during site-level failures, such as the AWS one. I think it's something which everyone knows, but sometimes it's worth a reminder. Visibility is key to any environment, from the simplest to the most complex, but HA depends on it. Without it, a failover may happen and everything may continue to work, but it's going to be a lot harder to understand what caused the issue, and it will take longer for a recovery. Mean time to recovery, or mean time to repair, MTTR, is a key operational metric here. If we lower the MTTR, the better the SLA compliance, the better the user experience, the better the user trust, and the lower the cost of downtime. So we've looked at the compute side of things with Power HA. So now let's take a look at the storage options. IBM recommends using Power HA in conjunction with policy-based high availability, or PBHA, on IBM flash system. They provide complementary layers of protection, especially for 3-site configurations. This combination blends the storage level automation of PBHA with the application-aware automation of Power HA. Some of the PBHA features are active-active architecture, meaning both nodes are active simultaneously. If one fails, the partition automatically moves over to the other system. We have auto failover. The volume mirroring and pathing is automatically managed. Talking of management, it's very much a simplified management. Linking the policy with the partition makes it easier to manage it through automation. And we've got capabilities for 3 sites. We can combine PBHA with asynchronous replication to a 3rd site for DR. This can obviously help with compliance to regulatory requirements such as DORA in the financial industry. And having policy-based DR enables recovery at a 2nd site if needed. Now we get onto one of my least favorite acronyms, as it's hard to say without getting it wrong. So Independent Auxiliary Storage Pools, or IASPs, allow you to separate your application data from the system itself, so that during a failover, you're not rebuilding, you're just switching. But, and this is the important but, IASPs introduce massive design complexities and considerations. Not everything lives in the IASP by default, and that's where many HA implementations run into trouble. Also, if your applications aren't ready or IASP aware, failover will not be clean. So on IBM i, that means you need to use journaling correctly. You need to ensure commitment control is consistent, and you need to make sure applications don't rely on system-specific paths or assumptions. Conversations about HA wouldn't be complete without talking about logical replication tools such as Mimix or Itera. Which sort of HA you use for your environment depends entirely on your requirements and sometimes budget. Power HA gives you very tight consistency and fast failover using IASPs and storage level replication. Logical replication tools operate at the object level. They replicate changes between systems, which gives you flexibility, especially over distance if you're using a 2nd data center. But they also introduce challenges like replication lag, object level conflicts, and more operational overhead. Many organizations actually use both. They'll use Power HA for the high availability, and they'll use the replication for the disaster recovery. So let's talk about the realities, because this is where systems succeed or fail. Not everything lives in the IASP. System level objects may need separate handling. So system level objects such as user profiles, system values, configs, etc. Network configuration and IP switching must be carefully planned. Getting that wrong means you lose the whole environment. And the most important bit is testing. You don't have high availability if you've never tested failover under real conditions. So what does good actually look like in these types of environments? It's not just about installing Power HA and crossing your fingers that it all works. You need applications designed for IASP. You need the full journaling strategy in place. You need regular and automated failover testing. You need the clear operational runbooks, and your HA and DR strategies must be completely aligned. So let's make this real for IBM I environments. Most organizations are at one of these 4 levels, which we see here. And where you are will often depend on the criticality of the systems that you're running. If you're able to live with an outage of a few days with minimal impact on the business, there's no reason to go on to a large extent. If you're one of these organizations where an hour's downtime is going to cost $5 million, then the expense of implementing true resilience pales into insignificance by comparison. So at level 1, you're relying on BRMS and backups. That's not about high availability, that's just recovery. Downtime is measured in hours or days. This is ideal for a test or development environment, maybe a legacy system which is needed to be maintained purely for compliance reasons. Old data, no active changes. Level 2 is where many IBM I shops start their HA journey. Logical replication tools. These rely heavily on journaling and give you that flexibility. But failover is often manual and not always clean. We actually see many organizations start and finish their journey here. This is frequently due to the business wanting to balance cost with resilience. Level 3 is where Power HA comes in, using IASP's storage level replication to enable that automated failover and much tighter consistency. This is where you start to get the predictable, testable outcomes. Some organizations stop here as they take the risk of the very rare outages as long as there's a very small RPO. They can often cope with a slightly higher RTO. Level 4, here we have the Porsche of resilience. This is combining HA and DR. Typically that means a local HA cluster using Power HA, plus a third environment on a different site using replication for disaster recovery. This is for those organizations with the large downtime costs. The key takeaway on IBM resilience isn't just about technology. It's about how well you designed IISPs, implemented journaling, and built operational discipline around testing and failover. So this may sound a little strange, but if you have to plan and build for failure. You need to assume that outages will occur, so you need to design for continuity and rapid recovery. The most resilient organizations assume failures will happen. Instead of trying to eliminate all risk, because that's completely impossible, they design systems that continue operating when something goes wrong, recover automatically when something goes wrong, and minimizes that business impact when something goes wrong. And possibly most important of all, resilient organizations test regularly. I've said it before, and I'll say it again. You're only as good as the last test. If you've never tested, you don't have a high availability environment. Even in the most controlled of environments, complexities can creep in, and it can have an impact on any successful HA failover. The key takeaways from the session today are Power HA, PBHA, and IISPs help protect mission-critical workloads with automated failover. High availability can and probably should be extended into a hybrid cloud of some sort. Combining automation with visibility improves resilience across the estate. Ultimately, operational resilience is not just about preventing downtime, it's ensuring that business continuity. So, thank you for your time. The challenge of maintaining uptime will continue to grow, but with the right resilience strategy, the right technologies, organizations can increase uptime and improve operational confidence. IBM offers the tools to make that happen. I will encourage you to attend many of the other sessions that we have during iAdmin. There is a lot of wealth of knowledge from our local experts to help you with your journeys as well. So I'd like to bring back Chad. I think we have a few questions being asked.
We do. Thank you, Phil. Yeah, wonderful. Definitely a lot of great information there. So definitely appreciate your expertise. One question that came in is someone inherited a Power 9 box running Friedman Frontier, and they depend on it quite a bit for their infrastructure performance. They're thinking about replacing that with a Power 10 or 11. What should they, of everything that you just covered, what should they consider implementing? What other considerations should they review as they develop their solution?
Wow. That's a big question. I think the answer is it's a definite maybe to all of those that we've just been talking about. It's absolutely right. You should be thinking about doing some of it. A lot of it is probably down to your business's attitude to risk and what downtime will cost you. Friedman Frontier, obviously, it's an ERP. They're obviously ERPs are generally the most critical system within a business. I'm on the sales side now, so sales will always tell you it's the CRM if it's separate. But ERPs are the lifeblood of your organization. So having downtime is probably not acceptable. So that's why many of them are designed to run on IBM Power, for example. If you can run your business without your ERP for a while, then probably you're fine with just running backup and recovery. If you can't cope with it for more than an hour or so, then yeah, you need to implement some sort of HA. Your individual requirements are going to be business based. It's going to be cost based. But obviously, if you want to talk to someone to help you with these sorts of decisions, please feel free to get in touch with your Service Express or Park Place contact.
Fantastic. Thank you, Phil. One additional question here. This person states that they don't currently use IBM storage.
Outrageous.
Outrageous, especially on this event, right? Who would have thought? Who would have thought? Can they still use PBHA or IASPs?
Wow. So now you're testing me. I would need to check something like this with some of our architects, but my initial reaction is PBHA is a feature of the IBM storage stack. So no, you're not going to be able to run it natively. But I think you should be able to use an SVC, SAN volume controller, to virtualize the other storage, and then the SVC can handle PBHA replication. IASP is part of the IBM iOS, so as long as the storage is compatible and supported by IBM, then I think this should be okay to use. But that's just off the top of my head. I would absolutely need to go and check with some architects to work